Hello there YouTube, this is the Aqua Student, and we're here with the 55-gallon African Cichlid tank, and a surprise. I've got a new project in the works. I picked up a 20-gallon fish tank at Petco the other day. They've got their $1 per gallon sale going on, so I took the opportunity to pick this up. I checked Craigslist a bunch of times, but all the used tanks in the area are just ridiculously priced. I'm talking like $150 for a 30-gallon tank. It's not right. But this really is all I needed to get this project started. It's something I've been wanting to do for quite a while, and I'm very excited that I now have the opportunity. So let's just go over a quick overview of the project and some of the complications I can foresee happening. So the biggest thing is I of course have the DIY foam and concrete background that looks absolutely awesome, and I love it. The one issue with it though is I'm not going to be able to drill this tank or do a couple of DIY PVC overflows off the back. That would be really easy if that wasn't there, but because of the location, the shape, and just kind of helping blend the overflows, I wouldn't really be able to do that. So instead what I'm going to end up doing is building one and placing it over in this left hand corner. It's pretty well hidden, and I could even probably build like some of the concrete rock work around the outside if I wanted to. In the meantime, I'll probably just end up painting it black and just doing this one step at a time. Anyway, so that's where one of the overflow into the sump will run. Sump will be housed underneath the tank, most likely on this right side, and then I can run the return line up into the right side. Now, I have a couple options. I don't think I'll be able to get it to fit inside the same chamber that the return pump from the Fluval 306 is going in. Even if I remove the heater and put it in the sump, I don't think there's enough space there. But I can always put it right in that corner. There's a nice little slot that's kind of hidden in shadow anyway. Paint it black, won't even notice it. So that'll work out nicely. I could. One of the things that I would like to do is even run a piece of PVC horizontally along the top, drill some holes in the side, and use it as more of a spray bar. I won't glue in that PVC to this joint here that it's coming into the tank at. That way I can rotate the PVC or the spray bar at any angle I want. I can add more surface agitation, get kind of a rain effect if I wanted, or direct it down directly into the tank. So now let's go take a trip over the whiteboard and go over some of the general plans that I have. Let's move on to the iterations or the progression of designs. The first one, cleverly named Design 1, starts off with a drip plate or something, maybe some drilled PVC, in order to spread out the water over some foam pads. This will remove the debris or whatever stuff that the biological media can't handle. Now, after the mechanical filtering, I'd like to try a fluidized bed. I think this would be a nice area to do it. It'll be completely underwater and work out nicely. After that, we're moving on to a wire, or basically a lock that moves the water up and will drop it again. The top of the wire will be just lower than the previous section, which will be lower than the tank rim. That way, if there's some sort of clogging, it'll overflow into the rest of the sump and not over the edge. So the drip plate will drip water over the grow stones. Now below that, I have a couple different options. It'll be kind of an empty area, but I could always put more media there, or I could go with an alternate design and ditch the second wire and just attach that into the Refugium. Now the only issue with that is I wouldn't be able to plant that left section beneath the grow stones because no light really would be getting to that area. But it would allow for more area for the fry or whatever fish are in there to move around. Now we'll hop over the next wire or into the next section with the Refugium, which will be fairly heavily planted. That'll help reduce the nitrates and will provide a semi-decent amount of water to add to the system. Now the issue with this design is only about half of the tank or so would be used for the Refugium or the pump out section. Now the problem with that is, so half of a 20-gallon tank is 10 gallons. Now we're only filling this up maybe 2/3 of the way, so we're down to about 6 gallons. and the pump will be about 3 inches high, so I can't let the water level drop below 3 inches or else the pump will overheat and burn itself out. So that means we're only dealing with about 3 gallons of evaporation, and in the summer months that could go pretty quickly. So that's why I jumped over to Design 2. Design 2 is a little bit more economical. It starts off with a pencil box or some sort of plastic container with drawers in it that'll act as a tower above the sump. The overflow will come directly into the top of the tower and start off with mechanical filtering. I can put in some of the drawers some foam pads or something. Now, if I'm going to do this, I'm going to need some sort of fail-safe to make sure that if the foam or the drawers clog up, the water won't overflow and go all over my carpet. In order to do that, I was thinking of drilling a larger hole and putting a PVC pipe in it that goes up to maybe 2/3 of the height of the drawer. That way, if the water level backs up to that level, it'll overflow into the PVC pipe and down into the sump instead of over the edge. Now, after the couple layers of mechanical filtering, I could go into the drip layer of grow stones. After that, we jump back into the sump, and I could go with the K1 fluidized bed or whatever sort of fluidized bed that I want to work with. After the fluidized bed, we'll go with a wire and into the Refugium. Now, what's good about this design is it's got a large area for the Refugium. This is probably 2/3, if not 3/4 of the tank that can actually be used for planting, and it can be filled up most of the way. This is good because the minimum maximum level or the amount of volume that I have to deal with evaporation is much greater, so I have a little bit more leeway. Now, originally I was just going to go with some sort of sponge pre-filter on the outside of the pump to prevent any sort of like plant matter or things like that from clogging it up. But one of the other things that I need to worry about is bubbles. So one of the options would be to go with a bubble trap right before the pump. Now, one of the downsides of this potentially is it's a smaller volume that I'm working with for the minimum and maximum water levels. I'd have to watch for evaporation much more frequently than I would with the larger Refugium. Now, one of the ways around this would be, instead of using a bubble trap, to instead use some sort of screen or drilled plexiglass. That's something that I'm playing with and will factor into Design 3. Design 3 is very similar to Design 2 with a few subtle differences. Once again, we have the tower on the side of the sump, but this time I could end up going with just all mechanical filtration and then some biological media below it with the grow stones. That way I could get the drip down into the sump and have more layers of mechanical filtration. Now, below that, I'd have some sort of directing wall to direct some of the water into the fluidized bed. Now, the fluidized bed would be housed by a screen or some sort of drilled acrylic piece instead of using the wire. Now, this has some advantages. It's a little bit simpler to construct, and it also allows me to direct where I want the water to come from. That way I don't have to have the water flow all the way up to the top. Once again, we have a large Refugium in the setup and a large volume between the maximum and minimum values the sump can run on. Now, one of the complications with this design is I'm not sure how many bubbles are going to be floating around the Refugium. I really don't want anything going in smacking into the pump. It'll lower the lifetime and possibly cause complications with the plumbing.